Next up, we have our HTTP and HTTPS protocols. Now, HTTP stands for Hypertext Transfer Protocol. You may have heard of HTML, which is Hypertext Markup Language, and is the language which Hypertext Transfer Protocol interprets to display web pages. HTML is the programming language which we use to develop web pages, and HTTP is the protocol which transfers those web pages, which transfers that programming. So our web browsers are going to be our typical program which pulls this Hypertext Transfer Protocol packets, and our Hypertext Transfer Protocol works over port 80 TCP. Again, TCP being our connection-based protocol, so we want to verify we have a connection with a web server and verify that all the packets we're getting are in order and they're correct. So over port 80 TCP. Now, when we're running over HTTP and we're using our web browser, what our web browser does is it sends a GET request to a web server for a particular page. So www.whichever.com, we're sending a GET request to that web server for its index page or its www page or whichever page it displays as its first page which it gives us. Because all in all, web pages, when they're being displayed to us, all they are is a file with programming inside of them. And we are asking that web server, we're asking to get that file. And once we get that file, it's transferred over to us with HTTP, and then our browsers interpret that into what we see on the screen. And then as we navigate through the individual web pages, we see slashes and we see different names. We're simply just on the same server going to different files on the same server. So web pages are just bunches of files and databases that our browsers are taking that information and interpreting. And the way they get that information is by sending a GET request over port 80 HTTP and then getting that information back. All information passed over standard HTTP is clear text. If you look at your URL and you see http:// whatever, all the information you see on your page is clear text, which means that it's not encrypted. So if hypothetically you were plugged into a hub or you're connected to a wireless, anyone else on that hub or on that wireless or anyone else that can sniff your traffic can see exactly what you're looking at. Because it's HTTP, it's all in clear text. There's nothing hidden about it. Now, we do need some web page information that we get to be encrypted. We don't want our bank account information to be clear text, because if all of our logins on our bank account information were clear text, anyone who was on our same network that could see our traffic, say anyone on our same wireless or anyone connected to us over a hub running Wireshark, can easily pull that information. There are some websites that are badly designed, that have very, very bad security, that maybe use login pages that are HTTP. And I've done demonstrations before where all you have to do is take Wireshark, install it on a laptop, install it on a computer, and then connect to that same network, and then use Wireshark to capture the packets. And the HTTP packet, which contains the login information, which contains the request and the sent login information, is very clearly marked and can very easily be found with a simple search string. You simply filter the packets that Wireshark has captured. It will show you the packets which match the filter that you applied, and you open one up and you say, oh, this is login information. This is the website it was that the user was at when they entered the information. This was the username and this was the password. That's if you're at a login page that is HTTP. So be very careful when you're logging into websites or you're creating a website and your login page. You don't want that login page or any pages where a user would be receiving confidential information to be HTTP. That's why you always hear when you're buying things online, make sure there's the little lock in the corner. Well, what is the little lock? The little lock means you're transmitting over HTTPS. And you'll see that when you're on login pages or when you're on pages where you're entering credit card information or doing purchasing, or even when you're doing some Google searches, because those Google searches may be information that you don't want to share with everybody. You don't want just everybody knowing what you're Google searching. you don't want everybody knowing about that scab that you have on your arm. You want that to be personal information. So HTTPS is HTTP Secure, and this is encrypted Hypertext Transfer Protocol. Now, this is going to transfer over port 443, and it's also going to be TCP. And this encrypted HTTP is going to be using a certificate between our client and our server in order to establish communications. And the information is not clear text. If I were to capture this information with Wireshark, if I were to be performing a man-in-the-middle attack and only sniffing your information, then I wouldn't be able to apply that same string that I did with HTTP logins and find your login information. Your login information is encrypted. I don't have the certificate between you and the server. So what is a certificate? Well, a certificate is a piece of information that we use, or it's a piece of data that we can use to encrypt our traffic between us and a server, that lets not only us know, but lets the server know that the other person is who they say they are. So let's say we're trying to connect to Facebook.com. Now, Facebook.com will issue a certificate if we're on an HTTPS page that says, hey, you're on an encrypted page right now, and here's my certificate to let you know that I am who I say I am. I am actually the Facebook.com server. I'm not FacebookHackerRussia.com server. So we'll be issued that certificate to let us know that they are who they say they are. Now, a fake website can have their own certificate. Just because a website has a certificate doesn't mean you should give them all your information. You don't want to go to HTTPS RussianHacker.com and give them all of your information, unless RussianHacker.com is a legitimate business. I haven't checked recently. But that certificate between the client and the server is simply the server letting you know that you are who you say you are, and the client letting the server know that they are who they say they are. So that communication can proceed encrypted, and that communication is going to be secure. The server-side certificate is letting us know that Facebook.com is actually Facebook.com, and it's not someone sitting over in the same coffee shop as us pretending that they're Facebook.com. That's what our certificate is going to do. So HTTPS is our encrypted HTTP. It's how we send information over the internet encrypted. There are still other security measures which we need to take in order to verify that that information is secure and that we aren't using a proxy that's taking our information, or we aren't hitting a particular device that is performing SSL stripping. But those are a little bit more higher level concepts that we may get into Security Plus, or maybe even later in this particular module. But all we need to know for HTTPS is that it's running over port 443. It stands for encrypted HTTP, and it's how we send information encrypted over the internet, and that it's a TCP protocol.